So what is left from the lecture 01.pdf is the concept called homophily, which is going to lead us to the definition of modularity. And modularity is a measure which is used in order to calculate or determine the number of communities and the communities themselves in a network. I have to mention that community detection is perhaps one of the most studied concept in network science. It attracts the interest of lots of people, and one of the main reason for this is that that it's difficult to calculate, and hence we have to come up with an efficient algorithm, and the interpretation of the result is quite straightforward. Okay, so formalizing the concept, the homophily, is something like this. That imagine that we have some classes in the network, groups, and then the number of these groups is denoted by NC. You can imagine that, or you can just think about like NC is equal to 2, for example. There are two classes in the network, and using this we are assigning a class to each and every vertex. Okay, this is going to be denoted by Ci. And now let's see how we can calculate the total number of edges that run between vertices of the same type. For this we are going to use the so-called Kronecker delta function, which does the following. So it has two arguments, two input values, and if they are the same, then the Kronecker delta returns with 1, and then if they are different, then it returns 0. And you can see that using this for all the edges, we are checking the end nodes, the endpoints of all the edges, and then we are going to check if they are in the same group or in different groups. And then we are summing up these numbers. We can use another formula for this. Now, instead of going through all the edges, we can go through all the nodes, and then using the adjacency matrix, which is equal to 1, I mean the entry at row I and column j, it's equal to 1 if there is an edge between node I and node j, and 0 otherwise. So you can see that this is an easy substitution of the previous formula. The only difference now is that we have to divide by 2 the whole thing, because we are dealing with undirected networks, where we are counting all the edges 2 times. So from I to j and j to I, and hence we have to divide it by 2. Okay, in the next slide, what we are going to calculate is the expected value of edges between all pairs of vertices of the same type. And this can be calculated by this formula. Okay, instead of reading the formula itself, let's see what does this mean. Just as a reminder, so with k sub I, we are going to denote the degree of node I, and m was the number of edges in the entire graph. Now consider a particular edge which is attached to a vertex I, and this I, vertex I, has a degree equal to k sub I. Now we know that by definition there are 2m end points of edges in the entire network. Okay, so of course the number of edges is equal to m, and then every edge has 2 endpoints, so it's obviously 2m. Now the chances that other end of our particular edge, so which is attached to I, so the other end of our particular edge is one of the kj ends attached to vertex j, is actually kj over 2 times m if connections are made purely at random. Okay, now what remains is that we have to count all these ki edges which are attached to our vertex I. So then the total expected number of edges between vertices I and j is then ki times kj divided by 2m. Okay, so this is here in the formula. And finally, if we are taking the difference of the two and normalize as well, then what we obtain is the so-called modularity. Well, I'm not going to repeat the formulas from before, so you can look it up in the previous slides. So by this one, what we are getting is basically it's a measure which is a number between 0 and 1, and then the larger the number means that we are, so a larger q value means that the graph has the network which we are considering or dealing with has communities inside. And there is a famous example which I don't really particularly like, but it certainly expresses very well this concept, is that it's a measurement, it's a social network from a particular high school in the US, in which students with different races are attending, and here, although it can't be seen very well, but you can perhaps see that students with black color and students with white color and well, other students, this is the part which I don't really like, so they are definitely forming groups among themselves, at least the black students and the white students.